Okay, fine. So today's lecture's topic is system of linear equation and echelon form. So let's go to the one note. Okay, so is one note visible? Just
Yes,
speak.
sir.
Yeah, okay, fine.
Yes, sir.
Okay, then let's go. Okay, so in this theorem, okay, so theorem. So every system of linear equations has no solution or has exactly one solution or has infinitely many solutions. Okay, so let's consider a system such that a11 x1 plus a12 x2 plus equal to a1n xn equal to b1 a21 x2 plus a22 x2 plus dot 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 a2n xn equal to b2. Similarly, am1 x1, here it should be x1, plus am2 x2 plus dot 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 amn xn equal to bn. So in this system you can see it has how many equations? Number of equations equal to, you can see, m. Okay, and number of variables equal to n. Okay, and in the matrix form you can write a x equal to b, where a equal to matrix a11 a12 dot dot a1n. Similarly, a m1 a m2 dot dot a mn. This matrix has the dimension m by n. Variable x has the form x1 x2 x3 xn. Okay, and b equal to b1 b2 b3 bn. Okay, so this is called system of equation. Okay, now I want to write in the augmented form. What is called augmented form of linear equation is like this: a11 a12 a13 dot dot a1n a21 a22 a23 dot dot a2n. Similarly, am1 am2 am3 dot dot amn, and there is a line which will be separated by b1 b2 dot dot bn. So this is called augmented form, which means that it is nothing but like this. Okay, so now I will introduce elementary row operation. What is called elementary row operation? Okay, is everyone are in? Okay, fine. Okay, so what is called elementary row operation? So in this, if we replace a system of linear equations by a new system which will have the same solution. Okay, so what are called elementary row operation? So in this we will have three kind of operations. First operation will be multiply an equation through by a non-zero number. Okay, so this is the first operation. In this operation, if you multiply an equation by a number, so the solution will remain same. In any equation, if you multiply by a non-zero number, the solution will be same. And in the second operation, if you interchange two equations, okay, in this case also the solution will remain same if we can interchange any two equations. Okay, so the third is add a multiple of one equation to other. Okay, so in these three cases, if you try to do any this kind of operation, the solution of that system of equation will remain same. Okay, so let's take one example. Example number 1. So suppose if you have x plus y plus 2z equal to 9, 2x plus 4y minus 3z equal to 1, 3x plus 6y minus 5z equal to 0. So this is a system of linear equation, and in the matrix form you can write 1 1 2. Okay, in augmented form you are writing 9 here. Okay, so here because b1 is 9, similarly 2 4 minus 3, and here 1 3 6 minus 5 and 0. Okay, now I want to solve this system of equation. So what will I do? First I will do elementary row operation. Any kind of operation I will do. So suppose I am doing is I'm changing row 2. Okay, row 2 such that row 2 minus 2 times of row 1. Okay, which means that I'm changing this row minus 2 times of this row. So what will be the new matrix? Can someone tell me what will be the new matrix?
1129 0 2 minus
1129
7 minus 17
0 2
2 minus
minus
7
7 minus
minus 17
17
3
0
6 minus
3 minus 11 minus 27, right? Okay, so this is the first operation. Okay, and what kind of row elementary row operation I did? This. Okay, this. Now I will do second operation. Now I'm telling that the
Sir,
system, whatever you got this system, it
sir,
will have the same solution as this system. Yeah, tell me.
the third row will remain unchanged. We haven't operated the third row.
Oh, yeah. Actually, I am doing one more operation. I didn't do that. Okay. I am changing row 3 as row 3 minus 3 times of row 1. Okay. Is it fine now?
Yes.
Yeah. So this is the first kind of operation I did. Okay. I mean, I changed these two row by this operation. Now I will do third operation. Now you can see that these two rows has changed. So I will write it as R3 dash. Now I am changing R3 dash because this is the new row. R3 dash such that 2 times of R3 dash minus 3 times of R2 dash. Okay. So what will be the resultant matrix? Can someone tell me? This first row will remain same. Second row will also remain same. Now third row will change because what I am doing is I did 2 times of this row minus 3 times of this row, which means that this will become 0. Okay, what will be this? Minus 1. Okay, and this will become what? Minus 3. Okay, so here I can also find solution from this matrix also. How? Now I will just replace whatever this coefficient is by this coefficient times that variable, which means that if you write x1, x2, x3, so you can write x1 plus x2 plus 2x3 equal to 9, 2x2 minus 7, x3 equal to minus 17, minus x3 equal to minus 3. From here also you can get the solution. How? You can see that in the third, I mean the last equation, you are getting x3 equal to 3, right? And if you back substitute this x3 into this equation, you will get what? If you back substitute, suppose I am substituting 2x2 minus 21 equal to minus 17. So this will be 2x2 equal to 4, then x2 equal to 2. Now I will back substitute x3 and x2 into first equation. So x1 will be what? 9 minus 2 minus 6. Okay, that will be 1, which means that you are getting solution x1 equal to 1, x2 equal to 2 and x3 equal to 3. Okay, but the thing is I am not doing this. Okay, I will move further. What will I do is I will do many more operations. Operation like this. What will I do is I will divide second row by 2. Okay, row 2 by, you can also write double dash or you can leave as it is, it doesn't matter. Okay, so R2 by 2. So what will be the resultant matrix? Resultant matrix will be 1 1 2 9 0 1 minus 7 by 2 minus 17 by 2 0 0 1 3. One more thing I did, that is R3 changed to R3 divided by minus 1. So row 3 has also changed. Okay, so you can see that what I did is I did this diagonal element change to 1. Now I will move further. What will I do is I will try to make this element as 0. So what will I do? I will do R1 change to R1 minus R2. So that will be 1 0. What will happen? 1 0, 11 by 2 augmented by 35 by 2, 0 1 minus 7 by 2 minus 17 by 2, It will look boring, but you have to understand what I'm trying to do here. Okay, now I will do fifth operation. Can someone tell me what I'm doing here?
Uh, we are uh, we are making a diagonal matrix.
I already made the diagonal, not, yeah, diagonal mat, but I'm trying to make it identity matrix. Okay, so it is already a diagonal matrix. Here also it is a diagonal matrix. Here also every matrix is a diagonal now. Okay, but I'm trying to make this as an identity matrix. So now whatever I will do is R1 change to R1 minus 11 by
We will
2.
get the direct value of x, y, and z.
Yeah, so now R2 change to R2 plus 7 by 2 R3. Okay, that will make the matrix 1 0 0 1 0 1 0, that will be 2 0 0 1, that will be 3. Okay, so yeah, now replace like this. So you will get x1 equal to 1, x2 equal to 2, x3 equal to 3. Now you will say, sir, why we are doing like this? If you could solve the system of equation like this, then why we are doing like this? You will understand why I am doing like this. Okay, so now I will introduce row echelon form. Why there is a need of row echelon form? Row echelon form.
Sir,
So yeah,
sir, by doing this, we don't need to solve the simultaneous equation, no?
I will tell you
For
why
follow this
we
approach.
need it. Here it is fine, but sometimes we will have many advantages. Suppose you have many system of equations and many variables. Okay, so you cannot do manually. Okay, so if you want to train your computer to do to solve the system of equation, then you have to write the algorithm. Okay, which means that you have to teach the code. I mean, you have to write the code and teach the computer to solve the system of linear equation if there are many variables. Okay, so it will have some algorithm. But here I know that in your gate perspective it doesn't matter, but still, if you want to try to find infinitely many solutions, then you will have many advantages here. Okay, so I will tell you why. So first I will introduce what is called row echelon form. So in the row echelon form, the first case is non zero non-zeros rows starts with a leading one. You have to remember this term, leading one. What is called leading one? Second, zero only rows go to go at the bottom. Okay, third condition, leading one. Here I have already introduced what is called leading one. Leading one in the lower row is more right than upper row. And fourth condition is called column with leading one have only zeros elsewhere. So if you meet only first three condition, this condition is called row echelon form. And if you meet these four, then it is called row reduced echelon form. In short, it is called RREF, and this one we called REF only, REF. So first you try to read what it is saying, then I will explain. First it is saying non-zero rows start with a leading one, which means that if you have a row such that it has non-zero elements, which means that not every element are zero, which means that if you have a row such that all elements are not zero, then it should start from 1. Okay, which means that if you have only one, I mean which you have not all non-zero, which means that it should start from 1. Now it is saying that zero only rows, which means that if you have such rows which has all elements zeros, which means that those rows should be at the bottom. The second condition it is saying like this. Now third condition is saying like the leading one, which means that whatever the row you have like this, okay, which means that this is called leading one. So in definitely you might have more than one leading row. So it is saying that if you have such rows, which means that that row which has the leading one in the below, it should be in the right side like this. I'm putting not 0 here. Okay, it can be anything. Now the fourth condition it is saying that if you have the leading one, okay, then in that particular row the every column element must be 0, which means that if you have this one is a leading one, which means that all other elements should be 0. If you had the leading one here, then all other column element must be 0. Okay, so this is called what? Row reduced echelon form. If you are meeting only first 3 condition, then it is called what? Only row echelon form. For example,
So can you explain the third point once again?
third point it is saying like leading one in the lower row. Suppose you have such rows which has the lower row, okay, which means that condition like this. Suppose you have 2 consecutive rows like this, 0 0 0 0 0 1 0 0 like this. Okay, then it is saying like this should be come up and this should be go down. Are you getting my point?
Okay, sir.
Yeah, which means that this should come down, this should go up, so that this element go, which means that after interchanging it will be like this, which means that it is going in the right direction. So that is the third condition. So let's take example. Suppose you have a matrix like this, 1 0 0 4 0 1 0 7 0 0 1 minus 1. Can someone tell me, is it a row reduced echelon form? Is it RREF?
Yes, sir.
Yes. Okay. Yeah. Now can someone tell me this one, 0 1 minus 2 0 1 0 0 0 1 3 0 0 0 0 0 0 0 0 0 0. Is it RREF? Yes. Now you can see that here this is the leading one. Okay, so it is meeting the first criteria, which means that non-zero row should start with leading one. So here you can see that it is the non-zero row. Okay, this one is also non-zero row, which means that it is starting from 1. Here also it is starting from 1. Now second condition, what it is saying, 0 rows only goes at the bottom. So these two are 0 rows, so these two are at the bottom. Now the third condition, it is saying leading one in the row, lower row is more right than the upper row. So you can see that here it is more in the right direction than this one. Now fourth, column with leading one have only 0 elsewhere. you can see that whatever it has the leading one, all column elements are 0. Here in this case also, here it is not leading column, so that's why it should not, it is not necessary that all elements should be 0. So it is also row reduced echelon form. Now I will ask third example. 1091, okay, 0012 0000. Is it? Tell me, is it? Is it row reduced?
Yes.
Other people?
Yes, sir.
Answer is no. Because you can see that this is the leading one, right? Okay, so in this leading one, you can see that there is a non-zero column element. Okay, so it is not row reduced echelon form. Okay, tell me, is it REF?
Yes, sir.
Yes. Okay, now take example number, not example number, next example. One one zero 010 000. Tell me, is it RREF? And is it REF? Is it RREF?
No, sir.
No. Is it REF?
Yes.
Yes.
Yeah.
Okay. Now we will see what is the benefit of this. Okay. So let's take a system of linear equation. Suppose you have augmented matrix. Definitely you can write in the system of linear equation. And in the augmented matrix, after doing all elementary row operation, you got this kind of matrix: 0 1 0 2 6 0 0 1 3 2. Okay, so you can see that what you did is, after what elementary row operation, you got this is A augmented matrix B. So now I want to write in the system of equation. So what can I write in the form of system of equation? Tell me. In the form of system of equations, what I can write? Tell me.
x1 plus 4 x4 equals minus 1.
x1 plus 4 x4 equal to minus 1.
x2 plus 4 x4 2x4
x2 plus x4
2x.
equal to 6, and x3 plus
So
x4 equal to 2, right? Okay,
2x.
okay, 2x4. Okay, fine. Okay, now you will see the benefit. Here you can see that in that particular leading row, whatever you got where the coefficient is 1 is exactly the variables. Okay, and other elements you can see like 4, other elements of the matrix like 4 2 and 3 are such that you can assume these 3 as a dummy variable. What I'm trying to say here is, you can see that you have 4 variables, right? You have 4 variables and only 3 equations. Okay, so definitely you will not have unique solution in this. I'm not trying to do any kind of nature of solution, but I am saying that here you can see that you have 3 equations and 4 unknowns. So what I can write is like this: minus 1 minus 4 x4 x2 equal to 6 minus 2 x4 and x3 equal to 2 minus x4. Now I'm trying to retrieve the solution. So you can see that these x4 are actually dummy variable. Okay, which means that you can assume anything here. If you assume x4 equal to t, then what kind of solution you will have? X1 equal to minus 1 minus 4t, x2 equal to 6 minus 2t, and x3 equal to 2 minus t. So this is the solution, which means that here t is any arbitrary real number. So you will have infinitely many solution. Infinitely many solution. So why? You can see that clearly you are able to separate all variables and dummy variables. And why it happened? Because you have changed the matrix into row reduced echelon form. Okay, so that is the biggest advantage, because you can clearly see that what are the numbers which are at the leading one are completely at the variable position. Okay, and all which are not that part are 0, and all those coefficient which are at the dummy position you can assume as a dummy variable. Are you able to clearly see this? Tell me. Tell me. Is there any problem here?
A row with a column with a non-zero row column will be taken as the dummy variable.
What? Please repeat.
I mean, the fourth column will be taken as a dummy variable since the other column has zeros in it. I mean, in the other variable positions.
Yes. So yeah. So that thing happened here. So it is easy to solve this. Now what? Yeah. So whatever. So here, what is that point taking is those leading one position. Leading one position variables are called, okay, those leading one position variables are called leading variables, leading variables, or pivot, or what? Pivots. Okay, now the second point is non-leading variables. Non-leading variables are called free variables. Free variables. Okay, so if you could found the number of leading variables, number of pivots, which means that if you have n number of variables, okay, and m is the number of pivots, then how many the number will be free variables? Tell me. If you have n number of variables, okay, and you have m number of pivots, then how will be how many there will be free variables then? N minus m. Okay, tell me, is it fine? So here you can see that,
Sir,
yeah,
sir, the leading ones are the pivots,
yes,
and the remaining
remaining variables are free variables,
Okay, sir.
which means that you can put any number of arbitrary real number. Okay, so that will be, these three variables will actually lead. Okay, and here t is dummy variable, or you can say free variable, which means that you can put any kind of real number at this position. That's why it has infinitely many solutions. Okay, so that is the advantage of what? Row reduced echelon form. Now let's take second example. Suppose you have augmented matrix like this 1 6 0 0 4, and it is augmented by -2 0 0 1 0 3 1 0 0 0 1 5 2 0 0 0 0 0 and 0. Okay, so how many leading variables and number of pivots? M equal to what? M equal to what?
Three.
M equal to 3. Okay, so free variables I will call it as a R. Okay, so how many free variables? N minus M. N minus M. So here the number of variables are how many? 1 2 3 4 5. So 5 minus 3 equal to 2. So which means that here the leading variable are this position and other will be free. So you can directly write as what? x1 plus 6x2 plus 4x5 equal to -2, and here x3 plus 3x5 equal to 1, x4 plus 5x5 equal to 2. So here you can see that these kind of variables are what? Free variables. Okay,
So how come n is 5?
n is the number of columns which are the variables, because how you are writing this matrix, this augmented matrix is in the form of Ax equal to b, right? So which means that this is x1 x2 x3 x4 equal to b1 b2 b3 f b4 b5. So which means that whatever here there will be number, suppose there will be n number, or here n equal to 4, then those number of columns will be multiplied by this. So that's why the number of columns will be equal to the number of variables. Okay, number of columns equal to number of variables. Okay, okay, so here there are number, you cannot count this because this is the column which is represented by the value b. Okay, so only this column, this are will number of column, these columns will represented as the number of variables. So here you can see x1 x3 x4 are leading variables. Okay, so x1 x3 x4 can be written in the form of free variables, which means that if you suppose if you take x2 equal to s, x4 not x4 x5 equal to t, then that will be -2 minus 6 x2, which means that 6s minus 4 x5 and 4t, x3 equal to 1 minus 3t, and x4 equal to 2 minus 5t. So this is the solution. Okay, now let's take another example. 1 0 0 0 0 1 2 0
Hello, sir.
0. Yeah,
Hello. Sir, why you are taking x pi equals to t?
here because here the free variables are x2 and x5. So that's why I took x2 as s and x5 equal to t, because this is the free variable. You can put any
Okay, sir.
value
Okay, sir.
here.
Okay.
Okay,
Awesome.
because the leading variables are only x1 x3 and x4 position, x1 x3 and at x4 position. So other variables are what? Free variables, which means that those variable we can assign any arbitrary number and any arbitrarily real number. So that's why I took x2 equal to s and x5 equal to t. Okay, it's fine.
Yes, sir. Yes, sir.
So now here, what is the number of variables? Tell me, n equal to what? N equal to what? You have to respond quickly, otherwise we cannot complete in time limit.
2.
Yeah. No, no, no. 3. 1, 2, 3. N is the number of variables. Okay. And M is the number of pivots. So how many there are pivots?
2.
2. Okay. So how many there are free variables? N minus M, which means that 1. Which means that you can write 2 variables in one any arbitrary real number. But here there is a catch. There is a problem here. If you write, suppose if you want to write in the equation form, so you can see that x1 equal to 0, x2 plus x3 equal to 0. But here you can see 0 equal to 1. Which means that 0 is not equal to 1. Which means that there is no solution. I'm not going towards that direction, the nature of solution. I'm just trying to make you understand how we actually solve the equation. Okay, I will go in that direction too. Okay, now let's move to the next topic.
So the conclusion is actually, do we need the REF or RREF?
This one,
Yes.
whatever I discussed is all forms are RREF form. You can see that this is the leading, and whatever in the leading position, there is no other non-zero numbers. Okay.
So
This
we
is-
can use this method only with the RREF.
No, I mean I am saying that if you could convert the augmented matrix in the RREF form, which means that you can clearly write in this form. You can clearly separate free variables and leading variables form. So that's why row reduced echelon form is very handy. But if you could convert only the row echelon form, then there will be a problem, because in that form the free variables and also leading variable will come into the picture. Then you cannot separate these two. But here you can easily separate leading variables and pivot variables. Sorry, pivot variables and free variables. So that is the biggest advantage of row reduced echelon form. And this,
So
yeah, tell me.
actually, there will be infinitely solution if you use this method, isn't it? So we won't be able
Okay, tell me if you have the unique
to
solution. If you
find
have,
unique solutions
okay,
using this method.
I want
Since
to
we are
ask.
giving an arbitrary value.
Okay, I want to ask one question. If you have unique solution, suppose if the system of linear equations has unique solution, then what will be RREF? What will be row reduced echelon form if we have the unique solution? If you could answer this question, then I will be very happy. Tell me.
I did your so it will be scalar, or I did only
Your voice is not
will be
coming
the
clearly. I am saying that whatever I discussed here is either it has no solution or infinitely many solution. Okay. Now I want to ask, suppose if the system of the linear equations has the unique solution, then what will be the row reduced echelon form? Can someone tell me?
Sir, there in row reduced epsilon form, there are dummy variables.
No, I want to ask, if you have the system of linear equations, suppose, okay, I will simplify. If the system of linear equation has n equal to n equal to m, which means that square matrix. If there is a square matrix like this, whatever there are number of rows is exactly equal to the number of columns. In A, there will be additional column
only
also.
there will be diagonals.
Only diagonal. I am asking what will be the row reduced echelon form. That will be identity matrix. Are you guys with me? If you have n equal to m, which means that n by n matrix, okay, I mean A is n by n matrix, then if you changed into row reduced echelon form, then all the number of variables will be exactly equal to the what? Leading variables. There will not be any kind of free variables, which means that all elements are at the leading position. Which means that what? It is identity matrix. But this will only happen when n equal to m. Is it fine? Which means that you can directly write like this. x1 equal to something, x2 equal to something, x3 equal to something, x4 equal to something. But this can only happen when matrix is square. If matrix is square. Tell me, is it fine?
So only if the matrix is square?
Yeah, because in other case, suppose you have the situation like this. Yeah, suppose it has finished only at this position. Okay, then you can see that the number of variables is not equal to the leading variable. There will always be a free variable, which means that you will not have any kind of unique solution. And suppose you have a situation like this. The number of rows are more than number of columns. Then what will you do? Suddenly you have to make it 0 here. Or if you could do, suppose you are trying to do 1 also, then in another operation it has to be 0 here. Then again it is not necessary that it will be unique solution, because suppose if you could not get 0 here, if some another number like b4, then there will be no solution, because 0 is not equal to b4. If you are enough lucky, if you are lucky enough such that here this coefficient is also 0, then you will have unique solution. But still not unique solution, another variable will have infinitely number of solution, because you can see that you have more number of equations and less number of variables. Are you getting my point, what I am trying to say? Tell me.
Yes, sir.
Should I move further?
So in the REF and RREF, do we need to make the bottom row as 0?
Your voice is not clear.
So if the do we need to actually make the bottom row as all 0? Is there any condition like that?
Yeah, it is condition of the RREF.
Okay.
Okay, but if you are meeting the only first three condition, then that is called what? Row echelon form, not row reduced. There is only one condition that is different from the row reduced, I mean row echelon, that is the column, the element in that particular leading one, that should be all 0. That is the only different condition from the echelon form, row echelon form. Okay, so let's move further. Now theorem. Now I will move to the homogeneous, then I will talk about the theorem. Homogeneous system of linear equations. Okay, a system of linear equations is said to be homogeneous if the system has the form like this: a11 x1 plus a12 x2 plus dot dot a m1 x1 equal to 0. And similarly n it should be n. Okay, a m1 a x1 plus a m2 x2 plus dot dot a mn xn equal to 0. So in the matrix form you can write ax equal to 0. Okay, so this is called what? Homogeneous. Okay, now there is a theorem. Every homogeneous system of linear equation is consistent. Consistent means what? It will have the solution. Okay, means all such system have x1 equal to 0, x2 equal to 0, xn equal to 0 as a solution. Okay, and this is called trivial solution. Okay, this is number 1. And the second part, if there are other solutions. Okay, they are called non-trivial. Okay, so what are you getting from this? It is saying that every homogeneous system of linear equation is consistent. You cannot find such homogeneous system which has no solution. At least you can get trivial solution. X1 equal to 0, x2 equal to 0, dot dot xn equal to 0. If there are other solution, those solutions are called non-trivial. Okay, I mean these solutions, at least this will exist. At least the system of linear equation has this solution, at least, and another other will be have. Okay, but this should be at least. Okay, so which means that there are two possibilities. So there are only two possibilities. Only two possibilities. First, only trivial solution, only the trivial solution, and second, infinitely many solution, infinitely many solutions, in addition to this trivial solution. Okay, let's take an example. Suppose you have augmented matrix like this. 2, 2, -1, 0, 1, augmented by 0, -1, -1, 2, -3, 1, 0, 1, 1, -2, 0, -1, 0, 0, 0, 1, 1, 1, 0. Can someone convert into row reduced echelon form? I will give you 1 minute. Just convert this. What is the time? Yeah. Convert this into the row reduced echelon form. Quickly.
R1 will be divided by 2.
Anyone? Did anyone get it?
Sir, R1 will be divided by 2.
What? No, I am just saying, I'm not asking the next step. I am asking what is the final row reduced echelon form. Okay. 1, 1, 0, 0, 1, and this will be always 0. Okay, so there is no point of write it. Has anyone get it? This? Tell me. So what is the n and what is the m? What is the n?
5.
How much?
5.
What is the m? What is the m?
4.
4.
3. 3.
3 only. This and this, sorry, this and this. These are the leading one. Okay, so what is the R2? Which means that if you write in the system of equation, you will get it x1 plus x2 plus x5 equal to 0, x3 plus x5 equal to 0, x4 equal to 0. So here you can see that these are the only leading variables, x3 and x4. Other variable you can write in another form, like suppose we are taking x2 equal to s and x5 equal to t. So what is the x1? Tell me. And what is x2, what is x3, what is x4, and what is x5? What is x1? Because for only these two variables you can put s and t, because other variables are what? Leading ones. And apart from that, other variables are what? Dummy variables or free variables. So there are only two free variables. Those are x2 and x5. So that's why you can substitute s and t at their position. So what is the x1?
Minus s minus t.
What is x2?
X2, yes, no, sir.
Yeah. That girl got confused when I asked what is x2. That is directly s, because at that position only you have substituted s. What is x3?
Minus T.
Minus t. What is x4?
Minus s.
0. And what is
Yeah,
x5? That is t. Okay, so you can see that there are infinitely many solutions.
T.
Okay, this is the case of what? Trivial solution. Okay, do you have solution like this? I mean, do you have the non-trivial solution in this? Do you have the non-trivial solution hidden in this? Non-trivial solution, sorry, oh, confused. This is called non-trivial, not trivial. Non-trivial. I'm asking, do you have trivial solution in this?
Yes.
When?
Sir, yes and T value 0.
Okay, when s equal to 0 and t equal to 0. Okay, which means that trivial solution is always hidden in the non-trivial solution. Okay, so yeah, so there are only two conditions in the homogeneous system of linear equation. Either you will get infinitely many solution or you will get trivial solution, and trivial solution is always called unique, and this is the multiple. Okay, the next theorem. So after this you can write a homogeneous system of linear equation with more unknowns than equations has what kind of solution? Tell me.
Non-trivial.
Hmm?
Non-trivial solution.
Non-trivial or infinitely many solution. Okay. Is there any problem here? Tell me. Okay, so let's finish today's lecture. Next class, I will talk about the how you can find the nature of solution based on the linear independence basis rank. Okay.
So,
Yeah.
Hello, sir.
Yeah.
actually,
Sir,
we actually say that if the number of variables are more than the number of equations, then there will
Okay.
be no